Let's look at this example of Poisson process, how to calculate probabilities if we know some random process is Poisson. Okay, let's look at the problem. We are concerned that there are accidents happening at an intersection, and the time interval between accidents has been analyzed, and it follows roughly the exponential distribution. We know that's important, with a mean time of 5 days between accidents. So the first thing we need to look at is the rate of arrival for this Poisson process. And because we have the mean for the exponential distribution is 5 days, so we have 1 over lambda we have the mean means 1 over lambda. That's the mean for the exponential distribution, and that's going to be 5. In fact, we can clearly see that the rate of arrival lambda is simply 1/5, or we say 0.2, and that's number of accident per day. And that's what we have, right? And so now let's look at the first question over here. Assume it is noon on Monday and an accident has just happened. What is the probability that the next accident will occur within the next 48 hours? So we know 48 hours, we need to turn this one into days. So 48 hours, and that's going to be 2 days, right? Okay. And from what we read over here, we want to find this probability. So we want to find the probability, okay, and the next arrival time is going to be less than or equal to 2. So this is what we want to find. Okay. Now, because of the duality, we know this is the same thing as saying that probability that in next 2 hours, the first one. So what we have over here is that N2 over here is going to be bigger than or equal to 1. Okay. And we can ignore the accident that happened at 12 noon because that's in the past. We know the exponential distribution has this property of memoryless. So we have this one over here. And then how are we going to calculate this? We can simply use the exponential distribution. We know the following thing, that the probability, the first arrival less than or equal to t, this is precisely 1 minus e to the negative lambda t, and that's what we had. So now, because our lambda, so since lambda over here we have is 0.2 and time t over here is 2, so what we have is that this probability that the next accident is going to occur before the end of the 48 hours is precisely 1 minus e to the negative 0.2 times 2, and that's going to be 1 minus e to the negative 0.4. Okay. And this value can be easily found using a calculator, or we just use this expression for the probability. Now, let's also look at if we can use the Poisson distribution to calculate, since we have this duality over here. So let's look at how we're going to calculate probability that N2 is greater than or equal to 1. That means still the same thing, that by time 2 we have at least one accident. That means the next accident arrives before the end of 2 days. And we can look at this one in the following way, because the complement is easier to calculate. So this is 1 minus the probability that n2 is less than 1. Now n2 is a discrete random variable, so we can say this is the same thing as 1 minus the probability that n2 is equal to 0, because that's the only possibility. And if we plug in the formula, that's going to be 1 minus. If we look at the formula over here, when k is 0, this is 1, and this is 1, and then we have simply e to the lambda t. So we still have e to the negative lambda t, which is 1 minus e. Lambda is the same, so 0.2 times 2. And then we still have, of course, the same answer, e to the negative 0.4. Okay. So this answers the question number 1. Now let's look at question number 2. So assume it is now 12 noon on Wednesday and no accident has happened since Monday. So we are in a lucky case. What is the probability that the next accident will occur within the next 48 hours? So this is the probability actually we are calculating. So what we are saying is that what is the probability that we will have the next accident will occur within the next 48 hours, and no accidents happened before, and we're going to use the property that this process is again memoryless. So this is the same thing as exactly what we have calculated. So next one we look at again is t1 and less than equal to 2. Still the same problem, and then we still have exactly the same answer over here. So the answer is exactly the same. It doesn't really matter. Okay. So let's look at now number 3. What is the probability that there will be at least 4 accidents next week? That means we have time 7. So we have over here t is equal to 7. That's the length of period. And we want to know what is the probability there will be at least 4. So at least 4. So we're going to count, that's what we have. So we will look at the probability. That means by time 7, end of 7, n7, and this one should be bigger than or equal to 4, because see, we have at least 4 accidents. And using the same strategy, this is going to be equal to 1 minus the probability of n7 less than 4. Less than 4, that means we have 1 minus the probability of n7 is equal to 0, and plus probability n7 is equal to 1, and plus the probability that n7 is equal to 2. And we have the last one, that's the probability that n7 is equal to 3. And then we plug in the formula that this is 1 minus n7 is equal to 0. We go back to the formula. So what we have is, let's look at the formula one more time. And this over here, so n7 is equal to 0. So we have t is equal to 7. And let's look at this formula over here. So we have lambda t, lambda is 0.2 and t is 7, that's 1.4. So, and we have to the power k is 0, and then we have e to the negative 0.2 times 7 again, and then divided by 0 factorial. Okay. So let's try to see this pattern again. So next one, again, minus n7 is equal to 1. We notice t is always 7, lambda is always 0.2. So we always have 1.4. So next time it's still 1.4, but now to the power 1 and e to the negative 1.4. and over here we have 1 factorial, and then we have next one 1.4 squared and e to the negative 1.4 over 2 factorial, and then subtract next one is gonna be 1.4 cubed and e to the negative 1.4 and divided by 3 factorial. So we get 1.4 because that's lambda t, and then lambda is 0.2, there's no change, and t over here is 7. So if we simplify this expression a little bit, this is 1 minus, we can pull out e to the negative 1.4, and then inside we have this is 1, and then this one over here is again 1, but it's 1.4, and then the next one is going to be 2 and 1.4 squared, and the next one over here is going to be 6 and 1.4 cubed. And this value is approximately, if we use a calculator, is approximately 0.0537. Okay, so let's see, by a calculator. Okay.